Okay, so after we figure out the line of best fit that represents the scatter plot, we can then talk about how strong the line of best fit is. And to do that, we use something called the coefficient of correlation, or the R value. And uh, what I've done here is I've taken this picture, I found this picture, and I think it does a really good job of explaining how R values tell you how well a line of best fit represents um, that. So it's not the line. So when we talk about the R value and we talked about positive and negative. Now remember, this is positive correlation because it goes up. This is negative because it goes down. Now we're not going to talk about what a stronger R value doesn't mean that it's a steeper line. Okay, this is not a better R value line than this one over here. Okay, and this is not a more negative R value because it's very straight up and down than this one here. Okay, what what happens is when we look at R values, we're looking at how tight the data is around the line. Okay, so if I was to draw a line, if I had some data, let me change to red here. If I had some points that were, spread out a little bit, and then I had another set of data that was pretty not spread out as much, and I drew a line, and I drew this line, and then I drew this line. Okay, two pieces of data. Both these have the same line of best fit, essentially. Okay, but the data is different, and what this relationship here would have a higher R value because the points are closer to the line overall than these points here. Okay, so this would have a lower R value than this. Now they're both positive, so when you talk about is it positive or is it negative, the line goes up, so it's positive. Okay, this is positive, this is positive. This is strong positive. So over here, this is perfect positive would mean that they land right on the line. Okay, high or strong positive correlation, the points are going up and they're tight to the line. Okay, these are all on the line. This, that's kind of a relationship that could be represented by the line of best fit, but now this number gets lower because it has low positive correlation. Okay, so it's not the steepness of the line, it's how tight the points are to the line. And then when we get to zero, a zero means no correlation. So a bunch of points, we do some research and we measure some things and we find out they have nothing to do with each other. So for example, if I said, what is the size of your shoe and how much TV do you watch? And you go ahead and you take all this point and you realize later on the points are all over the place. There's no relationship between the two things. And that's totally fine, okay, that there's no relationship. And a lot of times it's good when we find that out. People think, oh, you do a test and there's no correlation. And then you come back and you go, well, that was a bad test. No, it's not a bad test. It's a good test because you tested for something. Does this affect this? And you found out, no, it doesn't. Okay, so no correlation, not necessarily a bad thing. Low negative correlation, high negative correlation, and perfect negative correlation. So again, the numbers get bigger in a more negative way. So look over here, the numbers were 1, 0.8, and 0.3. The 1 is as high as you can go. And as we get close to 0 in the positive, it gets weaker. Now, in this case, remember we're talking about the size. When we're dealing with negative numbers, we talk about the size of the number. So the closer this gets to 1, the stronger this gets. Okay, the closer it gets to 0, the weaker it gets. Negative means it goes down. Strong means that it's all, perfect means it's all in line. High or strong, negative 0.8 is very close to the line. These are all kind of all over the place. This number will be lower because it's weaker. Okay, so weak, low, closer to 0. Weak, low, closer to 0. Positive because it goes up, negative because it goes down. Okay, hope that helps. And that's it.